Professor Molly's EKG course. I'm going to teach you how to identify basic EKG rhythms using my cardiac bundle notes. All right, follow along with me. So if you're wanting to understand cardiac dysrhythmias, you really have to understand the locations and the conduction systems in the heart first. So the primary pacemaker of the heart is going to start in the SA node, and that is going to generate an impulse located in the upper right atrium, and that is going to initiate a pulse between 60 and 100 times a minute. After the impulse is generated from the SA node, it is going to travel down to the AV node, and that's going to carry the impulse down to the bundle of His, through each bundle branch, and to the Purkinje fibers. And let's don't forget about the left atrium. You're actually going to have to go over to the left atrium in the SA node, and that actual branch is called Bachman's. Okay, now for the normal conduction system. So we've discussed how the pathway occurs. So when an impulse is generated in the SA node, then it's going to move into the atriums. Again, this is going to move into the right atrium and to the left atrium. And the atrium is going to depolarize, which means it's going to contract. Depolarization means contraction. That is where you're going to get the P wave. So when your atrium contracts, it's going to create that P wave. Then you're going to move down into your bundle of His and down each bundle branch to the Purkinje fibers, and that is where you're going to get the QRS complex. It's very large because the ventricles are large, and when it squeezes, it's going to generate a very large impulse. It's going to depolarize, squeeze the ventricles. What happens though, the repolarization, which is the relaxation phase, repolarization, is the atrium is going to get lost in that QRS complex. So you're never going to see the repolarization of the P wave. Then what's going to happen is you're going to see a T wave. That is the repolarization of the ventricles. So your ventricles are going to relax, and you're going to then start the cycle all over again. Okay, so I want to go back briefly to what we discussed at the very beginning, which is your SA node. Your SA node is your pacemaker of your heart, and that's where the impulses should be generated from. Now, you may hear the term ectopic beats, or ectopic rhythms. What you need to know about this is that if your impulse is generated outside of the SA node, it actually is considered an ectopic beat. So a beat generated like a PVC is an ectopic beat generated outside somewhere other than the SA node. Now you could have an ectopic rhythm. This is a whole rhythm that is generated by cells outside the SA node. Things like tachycardias, flutters, and fibrillation. So when you hear ectopy, these are things that are generated outside the SA node. Okay, next step before we start identifying dysrhythmias, we actually have to look at the cardiac cycle, and we do this by looking at a 1 second strip. Most of your cardiac strips are going to be 6 seconds, but we're going to break it down to 1 second, 1 box, 1 cardiac cycle. Okay, so first you have to identify the P wave. There's 3 things you need to do. Is it present? Is it upright? And is there a P wave before each complex? So that's before each QRS complex. If it is, you move to number 2. You're going to measure that PR interval. The PR interval starts at the beginning of the P wave and right before the Q wave. The normal range is 0.12 to 0.2 seconds. Then if that is normal, you're going to move to number 3. So now you're going to measure your QRS complex. Normal ranges range between 0.06 to 0.10 or 0.12 seconds. So this is measuring your QRS complex. And number 4, you're going to measure your R to R intervals. And we're going to do that in the next segment, but we're going to see if our R to R intervals are regular or irregular. And so that is going to be able to tell us if we have an irregular rhythm or if our rhythm is regular. One more step here is when we're measuring the PR interval and the QRS interval and using these little boxes in the grid to the right, what you'll see is we're looking at these little tiny boxes that are 0.04 seconds. And when you're counting each little box over, then you're going to multiply each little box times 0.04 seconds, and that's where you're going to get your range. So again, if I'm measuring the PR interval here, and I'm looking at the little tick mark right before the P wave and right at the Q, I'm going to count my little line. So I'm going to have 1, 2, 3, 4, almost 5 little lines. So I'm taking 5 times 0.04, and that's going to give me a 0.20 second PR interval. So that's how we measure, counting each little line and times it by 0.04 seconds. Okay, briefly going back to number 4, you want to make sure if this is regular or irregular. And so you do that by putting a little tick mark above the R wave. And you can use calipers or a piece of paper to see if it marches out. And if it does, it's regular. And if it doesn't, if each little R wave does not march out, then it's irregular. Now, to determine the heart rate using the strip below, you want to use the 6-second method. And you count the number of R waves, which is the little tick marks above each R wave in the 6-second strip. It has to be a 6-second strip. And then you times the number of little tick marks above the R waves times 10. There is 6 R waves, so this is 60 beats a minute. Now, if you use the big box method, you can count the number of big boxes, which is in between 2 of the R's. This can only be done if it's regular. If it's not, then you can't use this big box method. And then what you do is that when you count the big boxes in between 2 of the R waves, and you divide it by 300. And if you did this, there is 5 between the 2 boxes in front of you that you see. You divide that by 300 and it's 60 beats a minute. Okay, let's practice. So using this 6-second strip, you want to count the number of R waves and times it by 10. So let me know what you get. So if you were able to count 8 R waves, which there are, you times 8 by 10, that is 80. Your heart rate is 80 beats a minute. Okay, let's put this all together. So we're going to identify the rhythm, and by first looking at the rate. So we're going to look at the blue tick marks above the R wave, and we're going to count out, there's 8 of them, so that's 8 times 10, that's 80, so our rate is 80, and we're going to march it out. So you're going to see if the R waves march out, and they do, and they're regular. So then we're going to look at the P wave. The P wave, is it upright and present? It is for every QRS complex. So now we're going to measure the PR interval. The PR interval is going to start at the first little tick mark where the green hash mark is, and at the P wave, and to the end where the Q is, and that's the PRI. And that is going to measure 0.16 seconds by counting each little box. So that is 0.04 seconds. So there was 4 of them. So 0.4 times 4 equals 0.16. Now we're going to look at the QRS and we're going to measure that out. The QRS is going to be the beginning of the Q to the end of where the S ends. Those are the dark blue marks. And so that is, there's 3 little boxes there. And so it's going to be 0.12 seconds, and that's going to be the QRS. And this is a normal sinus rhythm because all of the PR intervals, the QRS complexes, it's regular, the rate is 80, and all of that equals to what a normal sinus rhythm would be. Okay, that concludes the basic parts of the EKG and the conduction through the heartway. Next, we're going to work on dysrhythmias. Follow me in the next course for that.